This week we're going to go over pointers in C++, but before we get there, I want to talk about memory locations in C++. Now we've already been using memory locations. We've been doing it using pass by reference. If you remember right, we add the and symbol, and when we do that, when a variable is updated in a function, it actually gets updated there and not just changed on that function level, but it actually gets changed back from the original location of the variable. To demo this, let's just go in here and we're gonna create our subfolders, right? So we want a source file, and I'm just gonna call them helper. And I like the CPP and HPP files is what I have as our convention, and I'm going to also create the header file so I can create both of them at one time. Remember, the implementation files where the full definition of a function goes, and the helper file is where only the prototype goes. So we're just going to do a test right now, so we're just going to call it, checkref, and we're going to pass in an integer, and we'll just call it x and semicolon. This is a prototype, right? So I'm going to copy that and come over to my implementation file and add it to my implementation file. And this is where we're actually going to define what the function's going to do. And so this, we're just going to do something simple like just change the value of x once it gets in. So in the main, we're going to call that, right? So we need an int variable of main x, and we'll set it equal to 2, and we're going to call that check ref of main x, and you can see it's having errors, and that's because I haven't included my header in my main file yet, but I'm calling my function, so I need to include that. So that's helper.hpp. You never put the CPP file here, you always just put the header file. And so it has that, and right, we're going to print out what's in main x. And we'll do the whole thing. So if we do this and we just compile it, I always like to hit compile first, make sure that everything runs, and then you don't get any warnings, and then run it again, or then run it. And you can see, right, our main x is still 2. Even though in our function we changed it to 42, it's still 2. But if we come in here and we add an and symbol to this, and I think if I hit compile, it's going to give me a failure, and the reason why is because they have to match, and I don't have them matching right now, so I need to also update this here in my header file, and I hit compile. Now everything works, and then I'm going to hit play. You're going to see instead of having 42, instead of having 2, I actually have 42. And the reason why is because this and symbol is saying pass the address location. So I want to say, where in memory is that? Well, we could actually look at that information with just printing out that and symbol data. So what we can do is here, right, so this is printing out the value of it, right? So what I'm going to do is I'm going to print out the main x, and it'll give us some data, right? Because it's always helpful for the user to tell them what you're doing. So the value of main x equals that, and I need that, and then I also want to, and the address is and I'm going to just use the same and symbol of that main x. Standard. So what this is doing, right, is I'm just printing out the address, I'm printing out the value, and I'm printing out the address of it. And so you can see here, right, we'll make it bigger so we can actually read it. The value of main x is 2, and the address is this. And so if we come over here to helper, what I'm going to do is add the same value again. I'm just going to call it x2. And we need to put it here as well, just so we can see it in one spot, x2. And in the function, what I want to do is I want to print out both values. So I'm going to say, we'll print out the address of both of them, and just the address. So we'll go standard cout, and it's not going to like that because I haven't included the IO string here. So standard cout, and then I'm going to print out the address of it, right? Well, we'll first say x address. And so we'll just do and, if I could remember, and x. And then we'll do and L. And then we'll do the same thing but we'll do it with 2. And then when we, in the main, when we call it, we actually are going to need to send the data twice. So we'll send the same data twice, right? So in both of them, so we can see the difference in the addresses. So you can see here, right? And I'll make it bigger so we can read. This is from the main value, right? So this is saying this is the address location of my x, the main x, right? That's it. And you can see the x address that we passed into it is that exact same address. But we passed in the same thing into the other one, but this is a new address. And so that's basically how address spaces are working in here, is that with arrays it's slightly different, right? Because arrays get passed in as by reference automatically. So just to show that you could still use the and symbol on an array regardless, we're going to just make a standard string array. I'm just going to call it array, and I'm going to have it have 5 elements. And then I just want to print out the values of the address, right? So I'm going to do a little something different. I'm going to say and array, right, with nothing, no square brackets on it. And then I'm going to repeat this a couple times. We'll do that many. And then I'm going to add some square brackets on it, right? So these are the elements of the array. Just so we could kind of see what's going on here. And, right, because this is, if you're going to pass in this array into a function, it passes in the location of the array, right? And then these are the actual elements of that array. So when we run this, what you would expect to see is that it gives you certain values in it, right? We're going to see the address locations. And you'll see here what happens is the first 2 are identical. And the reason why the first 2 are identical is because this is the address of the starting part of the array, where in memory it started the chunk of locations that are been assigned to array. And then this is element 0 of that. And then you can see this is element 1, right? So you can see this is a 20 difference here, and that's another 20 difference. And it's 20 hex, not 20 decimal. So you could see that, right? So that's because that's the size. It's 20 hex value is how big a string is. if I did the same thing, if I changed my array to an integer, I'm going to do the exact same thing, and I'm not going to change anything else. I'm just going to have it be an integer. You're going to see I have very different values here, right? It increases by 4 instead of by 20, right? And it's because an integer only takes 4 bytes, whereas a string takes, or 4, hex value, and then this one takes 20. So that's kind of how you can see the difference of sending memory locations. All right, play around with the code yourself, and I'll see you in the next video.